Hello everyone, how are you all? Okay, so we have completed our two lessons, okay, of term 2, that are body movements and motion and measurement of distances. Now let's start our new lesson, that is lesson number 13, fun with magnets. In this lesson we are going to learn some activities regarding magnets, then the poles of magnets and some properties of magnets. So let's start our session number 1. Okay, in this lesson I have not given aim and the keywords. Already keywords are given in your textbook, correct? At the end of your lesson keywords are given, so according to the session you have to write the aim and the keywords. Okay, I will give you the hint regarding aim. Okay, according to that you have to write down the aim of our first session and then write down the keywords. Understood? So in this session we are going to learn about the discovery of magnets and the main point. Okay, I am telling the main point. Actually we are going to learn 3 points in first session, that discovery of magnets, magnetic non-magnetic materials and poles of magnet. But the important points are discovery of magnets and the poles of magnets. Okay, so according to that please write down your aim. Yes, I know that the aim and the keywords are different. Okay, all are writing different aim, different keywords, so that's okay. Write down aim and keywords properly in your notebook in good handwriting. Okay, so let's start our first point, that is discovery of magnets. Okay, how the magnets discovered. So one story behind the discovery of magnet, maybe more than 2500 years ago, 2000 or 3000 years ago, the Greeks discovered a certain type of black stone that had the power of attracting pieces of iron. Okay, the story goes that Magnus, a shepherd, okay, one Greek shepherd was there, that is a Magnus. He had a stick with a small iron piece attached to one end of that stick. So one day what happened, his stick got stuck to a black rock, and it was found that the rock had the property of attracting iron. So like that there is a discovery of magnet. Okay, the Greeks named the rock magnetite. Okay, whatever magnets we are using that are actually a type of rock, that rock name is magnetite. Okay, so the Greek discovered our magnet. So magnetite is made up of mainly a chemical substance that is known as a iron oxide. So like that there is a discovery of magnet. You can see here I have make the slide of the discovery of magnet. You can see here, according to a legend, the first magnet was discovered by a Greek shepherd named Magnus. It is said that the nails in his shoes and the iron tip of his stick got stuck to a large black rock on which he was standing. Greeks named this strange type of rock magnetite. The Chinese also knew about magnets. Ancient Chinese sailors used magnets for navigation. Okay, so that we will learn afterwards. So like that there is a discovery of magnet. Understood? A simple story is there. A Greek shepherd discovered a magnet, as when he was there, he was standing on the rock and that rock attracted his stick, okay, which is made up of iron. Okay, at one end iron is there, so that stick was attracted towards that rock, and like that there is a discovery of magnet. Okay, and that rock name is magnetite. Understood the discovery? Yes. So see, what are the magnets? A magnet is an object that attracts other objects which are made up of iron, cobalt and nickel. See, now 3 sessions of this lesson we will learn through PPT. In last session we will revise all the things with video session. Okay, we will see the magnets that are available in our lab, then some experiments are there, some activities are there. Okay, so that we will see in our last session, okay, last video session. So please watch all the videos properly to learn, or to what we can say, that fun with magnets. Okay, enjoy the fun with magnets. So magnets are the materials which are made up of one chemical, that is iron oxide. Okay, magnets are normally made up of iron oxide, and they attract the substances which are made up of iron, cobalt and nickel. Means your magnets are not attracting all kinds of things. No, the things which are made up of iron, cobalt and nickel, only that things attracted by the magnets. So these magnets are in different shapes and different sizes. So you can see here the pictures of different kinds of magnets. See the size, see the shape of all the magnets. Okay, first one is the U-shaped magnet. You can see here, okay, the U alphabet is there, like that the magnet is there. Then bar magnet is there, means in rectangle shape. Then your ring magnet is there, and horseshoe magnet. Okay, so these are the different types of magnet which are available in different shapes and different sizes. Okay, so shapes are given like a horseshoe, ring, cylindrical and bar shape. But one thing, learn that the magnets are made up of iron oxide, and the magnets attracted the substance which are made up of iron, cobalt and nickel. So not all objects are attracted to the magnets. So according to this property, there are two types of material, that are magnetic material and non-magnetic materials. Okay, so see what are the magnetic and what are the non-magnetic materials. Objects that are attracted by a magnet are said to be magnetic. The examples are iron and nickel. Means what? The iron, cobalt and nickel metals are magnetic materials. Magnetic materials means what? They attracted each other. Means normally the magnet are attracting that. So when there is attraction between the two substances, means one is a magnet and the next one is a iron, nickel or cobalt. So that substances, that materials are known as a magnetic materials. Okay, iron means what? The substances. For example, if one chair is there, that is made up of iron. Okay, the small parts are there, or some windows are there that made up of iron. If you are putting the magnet on that, so that will stick to that iron substance or iron thing. So iron, nickel and cobalt are known as a magnetic materials. Not only iron, nickel and cobalt, the things or the material we are making from iron, nickel and cobalt, that are also known as the magnetic materials. Understood? Okay, and a magnetic material will contain at least one of these metals. Okay, means if any magnetic material is there in that iron, nickel or cobalt, okay, among iron, nickel and cobalt, if any one metal is present in that material, so that material will attracted by the magnet. Understood? Small definition is there. Objects that are attracted by a magnet are known as a magnetic materials. For example, materials that made up of iron, nickel and cobalt. Understood? Opposite to that, if the objects are not attracted by a magnet, are known as a non-magnetic materials. Understood? Like your wood, plastic, rubber, your clothes are there. They are not attracted by the magnet, and that's why that materials are known as non-magnetic materials. Understood? So you can see here the examples of magnetic and non-magnetic materials. Okay, your washer and iron fillings are magnetic materials. Okay, means magnet will attract these things. And in case of non-magnetic, that is your eraser or the drinking straws, then plastic, rubber, wood, these are non-magnetic materials. Understood? Understood? In non-magnetic material, the metals are also there, like your aluminium, then zinc or the copper metals. Okay, the things or the materials which are made up of wood, plastics, aluminium, zinc, copper, these are the examples of non-magnetic materials. Understood the difference between magnetic and non-magnetic? Okay, the simple points are there, easy points are there. See, I have given some pictures. Okay, find out that which one is magnetic material and which one is a non-magnetic material. Okay, so tell me, plastic ruler. Can plastic ruler attracted by the magnet? No. So plastic ruler is a non-magnetic material. What about safety pin? Yes, safety pin will attract the magnet or magnet will attract the safety pin. So that is a magnetic material. What about nails? Are they magnetic or non-magnetic? Very good, they are magnetic. Then what about papers? Very good, non-magnetic material. Feather, non-magnetic, and the metal door knob. Yes, these are the magnetic materials. Okay, so I hope that you will recognize which are the magnetic and which are the non-magnetic materials. Understood? Yes. Now the important point of our session, that is poles of magnet. See, you have seen that these pictures of magnet, whereas S and N are written. S and N. So what are that S and N? Can you tell me that? What are the S and N? So these are the poles of magnet. Okay, we will do one experiment in the video session. Okay, so from that you will understand easily what are the poles of magnet and what are they doing. So if a bar magnet is there or the horseshoe magnet or rod magnet is there, when they brought close to iron fillings, so that fillings stick at the two ends of the magnet. Okay, from the image also you can see here the iron fillings are attracted at the two ends of magnet. So that end portions of the magnets are known as the poles of magnets. Okay, N means your north pole and S means your south pole. Understood? Now understood what are the poles of magnet? If a bar magnet is suspended freely, that also we will do, it will always remain in the north-south direction. Okay, if you are hanging the magnet, so that magnet will show you the north and south direction, means it's suspended freely and it remain in the north-south direction. So this end of the magnet that points towards the north is called north seeking end or the north pole of the magnet. Okay, means if the N and S are not written on that magnet, you can find out which one is a north pole and which one is a south pole. But normally the magnet means on the magnets N and S are given. See what I have said, it will always remains in the north-south direction. Correct? Means by the position of sun you can find out the direction. Like by the magnet also we can find out the direction. So that we will see in next session. But understood what are the poles? Okay? If the magnet or the end of the magnet that point towards the north, it is north pole, and the other end which points toward the south is called south pole. Okay, so every magnet has a north pole and south pole, and this property is known as a directive property of a magnet. Okay, we will find out why every magnet points in the north south direction later in this lesson. But understood? See, when magnetic materials like iron fillings are brought close to a magnet, they do not stick evenly to all parts of the magnet. Means they can stick, but they stick more on certain parts of the magnet, that is the ends of that magnets. So that ends are known as the poles of magnet, and the magnetic forces are the strongest at the poles. So you can see here your magnet is making the magnetic field lines. See, if the iron nail is there at one corner, and if you are having a bar magnet, there is no attraction between the iron nail and that magnet if the distance is more. But if the distance is smaller, so that iron nail will attracted by that magnet. So that is because of the magnetic field lines. Okay, understood? So see the reason I have given that why poles are called north and south. So see, a magnet suspended so that it can rotate freely horizontally will eventually settle down with one pole facing north and other south. Okay, so one is a north pole and one is a south pole. So that magnet has been oriented by the earth's magnetic field. Means I think that you know that our earth is also act as a magnet. Do you know that when we are throwing something upside, that will come down because of what? Because of our earth. Because earth is also means what? Act as a magnet. Our earth is attracted that things towards itself. Understood? And this property is used by a compass. Have you seen the compass? See, this kind of thing. So this is an instrument with a magnet. Okay, magnet is also present in the compass, which we are using to find direction. Okay, the travelers are using the compass to find out the direction. So what is a magnetic compass? You can see here a small magnetic needle is present in this compass. So this needle is rotated freely and always points in the earth's north and south direction. Means the red point always show the north direction. Okay, if you will get the north direction, you will automatically find out the other directions. Okay, so different directions like north, south, east and west are marked on the compass, and with the help of compass we can find out the direction. Understood? The red point always shows north pole. Okay, if you get the north pole, opposite to that south pole. Okay, at your right side east and at your left side west. Okay, so automatically you will find out the direction. So like that there is a magnetic compass. Okay, in which the poles are used to find out the direction, that is north and south poles. Now another point is given that the directive property or the every magnet has a north and south pole. Okay, as I have said that each magnet is having two poles, north and south. But if we cut the magnet, if we cut the bar magnet, what will happen? The poles are different. Means the one magnet will show the south pole only and one magnet will show the north pole only. Like that will happen? No, it will not happen. If we cut a bar magnet in half, then each half becomes its own bar magnet with north and south poles. Means what will happen when we cut this bar magnet? This part will act as a north pole and this part will act as a south pole. Okay, means we can't separate the magnetic north pole from its south pole. Understood? Okay, the electricity and magnetism, these points are not for your class. Okay, you will learn that electricity and magnetism in higher classes, but only remember that if we are cutting the bar magnet in half, still we can't separate the poles. Okay, we can't separate the north and south poles. Understood? See the magnet to find the direction, that we learn that about the magnetic compass. So see, today we use magnets for various purposes. That uses we will see in third session. Okay, in ancient times, the primary use of magnet was to find direction. So what they were doing, if a magnet is allowed to move freely, okay, that one activity is no, that string is there, then if we are hanging that magnet with that string, so that will always remain in the north south direction. So this property of a magnet was used to find direction on the surface of the earth by travelers. Nowadays also we are using the magnetic compass to find out the direction. Okay, you can see here what is actually happening. So this is your compass and this arrow will show north point only, or your north direction. Okay, the arrow always point towards north, and then we will find out the other direction. Understood? Another question is there, why the magnet is always points the north and south direction, why not east and west? So see, one reason is given. The earth itself is like a giant magnet, correct? Earth is also attracted the things that we are throwing. It has two separate magnetic poles, means earth is also having the magnetic poles. So these poles are close to the earth's geographic poles. Geographic poles means what, maybe you have learned in social studies. Okay, the north pole, then south pole, east pole and west pole. Have you learned that? Northern hemisphere, southern hemisphere. Okay, so that positions are the geographic poles. But earth is also act as a magnet, which are having the magnetic poles. Okay, a freely suspended magnet responds to the magnetic force of the earth and then points in the north and south direction. Understood? And this property of a magnet is used to make a compass. Understood? And means what? The needle in the compass is actually a magnet, and that's why it shows the north and south direction. And that is why no matter where you place the compass, its needle will always point in the north and south direction. Understood? See the reason I have given, and you have to learn that reason. That do you know why a freely suspended magnet always points in the earth's north and south direction? So what is happening? It behaves like it is under the influence of another magnet. But where is the other magnet? Which is the other magnet? Yes, your earth is the other magnet. Okay, it is the earth itself. So this alignment happens because of the influence of the earth, which itself acts like a giant bar magnet. Means your earth acts like a bar magnet. It influences all the magnets within its region of influence to align themselves along its north and south direction. So because of the earth, the magnet suspended in north and south direction only. Understood? So that is the reason behind that. You can also make your own magnet. So what you have to do, take an iron bar and a magnet bar, place one of the magnet's pole at the edge of the iron bar, then slide the magnet towards the other edge of the iron bar without lifting the magnet. Leave the magnet now placed at the initial position again with some pole touching iron bar. Repeat this process 30 to 40 times or more till the iron bar becomes magnetized. Means what we have to do, you can see here with the help of diagram, you can make your own magnet. Okay, so though follow the procedure that given in your textbook, or you can follow the procedure that I have given through the slide. Okay, so it is not a necessary part, but you can also make your own magnet. So it is possible to make magnet. Understood? So here we have completed our first session, in which we have learned about the discovery of magnet, then the magnetic and non-magnetic materials, and the poles of magnet. Okay, when I will share the PPT with you, write down the important points in your notebook and learn that. Okay, complete the table 13.1 that is given in your textbook, and means think and solve that table 13.1. Okay, still stay home, stay safe, and thank you.